Assalamualaikum and greetings. In this video, we're going to take a look at the nucleophilic substitution reaction for carboxylic acid derivative. Since the carboxylic acid derivative is derived from the carboxylic acid homolog series, they're going to share the same common reaction. In this case, it's the nucleophilic substitution reaction. So in general, if we have the carboxylic acid or carboxylic acid derivative, it can be written off as RC double bond O, which representing the carboxylic acid family, and it attached to a leaving group where we write it as L, and then we're going to further react it with a nucleophile which attach to a hydrogen. So what's going to happen next is we need to identify the carboxylic acid part, in this case the RC double bond O, and then we assign letter A to it. The rest of the leaving group will be assigned as B. Next, we take a look at the next reagent. In this case, we're going to divide the nucleophile and also the hydrogen. The hydrogen will always be assigned as A prime, while the nucleophile will be assigned as B prime. So, we're going to do the substitution between the partner. The A will combine with the B prime, while the A prime will combine with the B. So if we rewrite back the structure, it will be looking like this: R C double bond O attached to the nucleophile. And as you can see here, the nucleophile is the B prime, while the RC double bond O is the A. Next, we're going to have another side product, which is H from the A prime, and then it's going to combine with B, which is the leaving group. H will be the A prime, while the L leaving group will be B. This is the general formula on determining what is the product of the nucleophilic substitution for carboxylic acid derivative. Again, the rules are it must be a reaction between carboxylic acid or carboxylic acid derivative which reacted with a non-carboxylic acid carboxylic acid derivative. The non-carboxylic acid derivative should contain hydrogen so that we can perform the nucleophilic substitution reaction. Let's take one of the carboxylic acid derivative as the example. Let's say we're going to use butanoyl chloride. Butanoyl chloride consists of 4 carbon attached to the C double bond O and then attached to Cl. And then we're going to react it with something which is not from the carboxylic acid or carboxylic acid derivative family. For instance, just now is water. The water can be written as HOH so that we can isolate the hydrogen part. And before we proceed with the products, we need to identify which is the AB and also A prime B prime part. So for this structure, the A part belongs to the C double bond O with the alkyl attachment, meaning that we're going to divide the structure here and then we assign this as A and the Cl will become B. For the water, again, we're going to divide it into 2 parts, whereby the H will become the A prime. It will be always the H will become the A prime. The rest of the attachment will become B prime. So what's going to happen next is we're going to switch the partner. Remember, it must be a combination of AB. Therefore, in this case, the A will combine with the B prime, while the A prime will combine with the B. So we can proceed with the product. It will be looking like this: 4 carbon, C double bond O, which representing the A part, and it's going to attach to the OH, which is from the B prime from the structure of the water, and the side product H from the water, which will combine with the Cl from the butanoyl chloride. This reaction is also known as hydrolysis. In another example, we can also react it with alcohol. For instance, let's take a look at isopropyl alcohol. Isopropyl alcohol is a 3-carbon which attached to the OH group. So basically, as you can see here, there's hydrogen on the oxygen, there's hydrogen on the carbon-carbon chain. However, we'll be focusing on the hydrogen from the OH since this is the functional group for alcohol. So again, we're going to use the same approach. We're going to identify the A part of the structure, which representing the RC double bond O. While for the alcohol, we're going to identify the hydrogen part. So in this case, we're going to break down the bond between the hydrogen and the oxygen. And remember again, hydrogen will always be assigned as A prime, and the rest will be assigned as B prime. So if you want to draw the product, it will be looking like this. The 4 carbon from the A part is going to attach to the B prime from the alcohol. So as you can see here, the bond is being broken at the oxygen, so it needs to attach to the oxygen first, followed by the attachment to the 3 carbon. And the side product will be the hydrogen from the alcohol, which is going to combine with the Cl from the butanoyl chloride. Therefore, in the end of the reaction, you will obtain the compound ester. Okay, it is consists of the alkyl group RC double bond O, which combine with the alcohol part. So the name of the reaction is the esterification. Both of the hydrolysis and also the esterification having the same mechanism, which is the nucleophilic substitution reaction. Okay, let's take a look at another example. For instance, we're going to take an anhydride. So we're going to start off with benzoyl anhydride, which consists of the benzene ring attached to the C double bond O, attached to the O, attached to the C double bond O, and another benzene ring. So this is the benzoyl anhydride, which is also considered as a symmetrical anhydride. We're going to react it with ammonia. The formula for ammonia is NH3. We can also rewrite it back as H and H2, since we're going to take the hydrogen as the A prime. So before we begin the reaction, we need to identify which is the part for carboxylic acid and also which part of the hydrogen that to be substituted. Since this is a symmetrical anhydride, we just can simply take one side of it, make sure it is consists of the alkyl group connected to the C double bond O, while the rest will be assigned as the others, which is B. This part will always be A, and then for the ammonia, we're going to separate the hydrogen. Then hydrogen will become A prime, while the NH2 will become B prime. We're going to switch the partner, where the A will combine with the B prime, while the A prime will combine with the B to produce this following product. The A structure comprises of a benzene with C double bond O, which then attached to NH2 from the B prime. The side product will be H, which is from the A prime connected to the B side, which comprises of the O, C double bond O, and then finally we have benzene attached to it. In this example, as you can see, we produce an amide here, which is benzamide, and of course this one is a carboxylic acid, which is benzoic acid. This reaction is also known as ammonolysis, because we react with the ammonia or its derivative. Let's take a look at the example for esters. Again, nucleophilic substitution is a reaction between a carboxylic acid derivative with a non-carboxylic acid derivative compound. So, if we are using esters, for instance, the 3-carbon esters attached to the oxygen and attached to the benzene group. This compound is named as phenyl propanoate because the alcohol part is being represented by the benzene group, and then we're going to treat this as a phenyl from the alcohol part, while the other side having 3 carbon and from the carboxylic acid part will be considered as propanoate. So the name will become phenyl propanoate. We're going to react the ester with the strong base. For instance, sodium hydroxide. We're going to do the same process. The first one, we're going to determine which is the carboxylic acid part, and then the other one, we're going to determine the location of the hydrogen. In this example, the part A for the ester is represented by the C double bond O, which attached directly to the carbon-carbon. So we're going to break the bond here, and then we're going to assign A and B here. For the other compound, always remember that the A prime is always the hydrogen, while the partner will become the B prime. Again, for any nucleophilic substitution for the carboxylic acid derivative, we're going to switch the partner. So the A with the B prime, while the A prime goes to the B, which resulting into the 3 carbon of the carbonyl compound attached to O and A. Again, we're going to attach the carbon to the location where the bonding is being broken. And the side product is H from the A prime, which will connect to the oxygen followed by the benzene ring. If you think that the end product is a phenol, you are correct because it is a benzene attached to the O and finally attached to the H. This is the side product of the reaction. For this reaction, it can also be called as the salt formation reaction. The mechanism involved is a nucleophilic substitution reaction. The nucleophilic substitution reaction for amide is limited to salt formation and also hydrolysis, since amide is the least reactive carboxylic acid derivative compared to the rest. When butanamide reacts with sodium hydroxide, for instance, we're going to use the same approach. First and foremost, we're going to identify the A part from the carboxylic acid. So we're going to cut down here and then identify this as A, and the connection to the NH2 will be considered as B, while for the sodium hydroxide, we're going to isolate the H so that the H will be considered as A prime, and then the rest will become B prime. So the end product should be looking like this. 4 carbon with the C double bond O is A combined with the B prime. So we can get O and A as the attachment plus the side product, H from the sodium hydroxide attached to the NH2 from the amide compound. So if we rewrite back this again, you know that this is a ammonia. The final example, let's say we have a benzamide, which is benzene attached to the C double bond O attached to NH2 plus water. And remember guys, any reaction involving water should be conducted in acidified medium. We're going to use the same approach. Okay, we identify the A part of the structure together with the B part from the structure, and for the other one, we're going to identify the H as the A prime while the OH as the B prime. Then we're going to do the switch where the A will combine with the B prime while the A prime will combine with B. So we can get our product. This is the benzene together with the C double bond O, which is attached to OH from the water plus H from the water and attached to the NH2 from the benzamide to give the same side product of ammonia. Please leave a question at the comment section for review. Thanks for watching.